All right, so hello everyone. Are you able to hear me clearly and see my screen clearly? Great, great. Wonderful to have all of you in the session. All right, I'm going to give all of you the ability to record the video. Allow record, allow record, allow record, and okay, I can't give permission to Rajan on iPad. Okay, Hitendra, allow record, David, and my host, Aniket. I'm not able to give you the permission to record. I think on phone it's not allowed or something. Okay. Grisma's question is that yesterday's video is not yet uploaded, right? I think it'll be uploaded by tomorrow morning. Okay. All right. Okay. A question from Robin is, all right, before we start the session, we have one question. Okay, so all right, let me just put the question here so that everybody can see. Just an observation, the query parameter C create table below. Okay, I'll just allow Grisma also to. Okay, Grisma, you already have the permission to record. And okay, Subbu, I think I have given you the recording too. All right. Okay, great. So let me just take a look at this question. Okay. All right. So Grisma, you could try using the database, and so you are using the use command along with this. Try using the use command with your database name, and then that should work. Okay. All right. Great. So I'll take a look at it separately, and then probably the kind of errors that we were getting yesterday that we can do. All right. Just drop us an email at reach us. Okay, and somebody from my team could answer. Okay. A question from Robin is Robin is that the query parameter C create table below showed the table in the query result after executing use rf underscore 10 March 18 describe formatted NYC. However, the query parameter C create table below did not show the table in the query result. Okay, and also it created NYSE folder in my Hue warehouse folder. However, there is no content. The table isn't there. All right. So, okay. All right. Here, after you create the table, creating the table will not create the data unless you upload something into it. No, sorry. Creating the table would create the folder, but there won't be any content in that. Okay, there won't be any content in it. So you will have to load data into NYSE. Did you load data, Robin? Into this. So you use this database you created, which must have created an empty folder, and you will have to upload data into this. Okay. A question from Rajan is, if you are recording every session, can you point me to where it is kept? Only my page I can see Jan BDHS ILT Jan 28, but it has only one session. Let me just take a look at that. Okay, so here CloudxLab, and then Sachin, you already have the permission to record. Sachin Sikri, right? Or do you have multiple accounts? I think you already have. It is showing me only forbid record option, not allow record option. Okay, all right. So in the beginning of the session, I tried to give everybody the permission to record. And if some of you have left, just let me know. I could fix it. Okay, all right. Let me just see if, okay, I'm just giving everybody the permission so that, all right. So I'm just giving everybody the permission to record. It takes a bit of time. Now let me, okay. Okay, so first let me complete that question of Robin. Let me just answer. So here, basically, we have not loaded the data. You'll have to load the data because you have just created the table. All right, you'll have to say load data from such and such table and so on. Grishma, the code that Grishma has suggested, similar code should do that. All right. The second question is from Rajan. Rajan is only able to see BDHSILT Jan 28. So what you can do is you could go to my courses. Okay, there, this one, BDHS, is this the one? Jan 28. Is there any? Yeah, this one. Okay, okay. All right. Actually, the confusion is here to everybody. Please pay attention. So here it is basically only one thing inside it. If you click on Start Now, then you will see all of these videos. Okay. So the UX is something lacking. So it gives an impression that there is only one video, but there are multiple videos. Okay. All right. So this is for all. Probably you can take a look at this. So you'll have to see this. There are all sessions recorded here. Okay. All right. Okay, Maruk, you already have the permission. Please check. I've given the permission to all of you. Okay, so that's pretty much here. All right. So did you copy this NYSE daily folder the way we did yesterday? First, you have to copy this NYSE folder from /data folder into your home drive, and then try loading data from that. Load data in path this, overwrite into the table this. Okay. All right. All right. Could you, yeah, can I take a look? You could show me the screen and then we can move ahead. Go ahead, show the screen so that I can help you. Okay, so create this. All right, you've already done this part, so nothing to worry. And then this is okay till this. Okay, go down. All right. Okay, say select star from there. Say select star from the table and then let's take a look. After use. Okay. Use the folder as well, please. Yeah, use select use as well as the select star, because whenever you since you have not okay, so yep, just select both lines. Yes. There. All right. So there is nothing in there. Now let's load the data. Can we take a look at your file folder? Let's load the data. Okay. Yeah, that's the one. Okay. So all right. Now, I would like, before running this command, okay, one is use RF, that one. Okay, good, good. And let me, okay, use the use command here before this. Okay. Now, let me take a look at this folder in your home drive. Is it there? Right click on the file browser. Oh, good, good. Okay, click there. Yeah, this is no, in your home drive. Okay, was it there? All right, go into that. Oh, good. It is there. So it's not there. Actually, you'll have to copy this file. Okay. You'll have to copy this to your home drive, home directory in the folder. Okay. Go back. So you'll have to copy. You'll have no. You go back to the file browser. I'll explain. Since see here you are loading from your home drive, right? You'll have to have this folder in your home drive. So copy this in your home drive, and then we'll load it from there. Okay. How do you copy? Just go to data folder, click on data folder. Okay. Yeah, good. Select the folder NYSE daily. Yeah, then click on actions and copy, and actions and copy. That's correct only. N- Okay. Okay, remove that from text box. All right, let's copy that folder once more again and then take a look at the folder above folder. Yeah, just copy it to your home drive. Click on home. There's a home folder. Click on home. Yeah. All right. So I think looks like you already have a file there in your home drive, a folder there in your home drive. That's why it's giving the error. Right. So just then in that case, just copy the file alone. There is already a folder in your home drive. Click on home drive. Yeah. So I think there is already a folder. That's why it will give the error. So you might have to delete that folder and then copy this. Go to your home drive, home folder. Go to your home folder. Delete this one. Yeah, delete this file. Yeah. Now try doing the same thing. Just select the folder and then copy it. Did you copy that in your home drive? Home folder? Can you check? Is there a folder with name nyse_daily in your home drive? Click on home. Okay. Okay, click on that. Yeah, this is correct. It's not working. Click on execute. Yeah. There's a special code. You see that after NYSE daily, right? You see there is a code. Can you just change it to single quote normal? Yeah, that one, the one. Because whenever you copy something in your Microsoft Word or Google Docs, these kind of special codes become a big nuisance. Okay. All right. So it looks like it is working now. All right. Wonderful. Wonderful. And yes, I'm happy that everybody is able to do the hands-on. Great. All right. Good. A question from Sachin is that I'm a Java developer. I do not know PLSQL. What is the scope of Java in big data? All right. For Java, I think you will be, there is a lot of scope you will see as we go ahead. For you, even though we'll talk about Scala here, for you, the Scala will come really easy. Second, MapReduce in past has been written in Java. So there's definitely a lot of scope. The entire Hadoop is written in Java. So there's a lot of scope there. Also, because these are two different questions, right? So first one is what's the scope of Java in big data? There's a lot of scope. Second is I don't know PLSQL, so should I stick with only Java? No. My suggestion to you is learn SQL. SQL is kind of must to learn. So not necessarily PLSQL, just learn the basic SQL. That'll be good. Okay. So I will suggest that you must learn SQL. Okay, no matter which background are you in, no matter what is your plan, whether you are in completely hands-off manager who don't do much of hands-on, or you are an engineer, developer, or you are architect, you are a DBA, or you are a sysadmin. For everybody, I would strongly suggest that you must learn SQL. Okay, just learn the basics of SQL. Whatever we discussed in the session, if you were able to understand what was going on, like why we created table, what does it mean by select star, why did we do the grouping and wrote the query, then you should be already good at SQL. So no matter what background you come from, you must learn SQL. That's kind of must have. A question from Robin is just another observation. If I delete a table or database at Jupyter Terminal, it gets deleted in Hue folder. Why is that when I delete a table at Hue, it stays? No, actually it does. It won't get deleted in Jupyter. You try doing something else. Okay. So if you are using, Hive console and you are saying drop table, then it would get deleted. Okay, all right, but so that's the way Hive is designed. Hive is designed to drop data, delete the underlying data folder in case your table is managed table. So let's say you created a table, now you're dropping it. The underlying data, as in the warehouse, the underlying data will get deleted. Okay, while if you delete the underlying data, the table will remain intact. All right. So a question further from Sachin is, can you give a reference link for SQL? I would suggest that there is a nice tutorial at W3C. You can start with that. Okay, can you start with that? But we can also plan something. Okay, we can also plan something, a small session on SQL. It's a long overdue, so we could do that. All right. A question from David is, there's a difference between PL/SQL and standard SQL? Yes, thank you, David. So I was coming to that. So yes, so you should focus on the standard SQL. Thank you, Noor, for the link. Okay, and that would definitely help you. Correct. Thank you, Noor, for that. It will be easy for you. I completely support Noor for that. Okay, great. And all right. Okay, load data essentially copies the data into the Hive folder the way we manually copied, and hence makes the data available for Hive to query on it. All right. A question from Robin is CloudxLab just for lab tests, training, and simulation, or does it also provide Apache Hadoop and Spark-based software support and services? We don't yet provide the support and services to the industry, but we can think of something. Okay, we are open to the experimentation. So in actual job function or enterprise development, can we use them in production as well? So yeah, so Apache Hadoop and Spark definitely can be used in production, but CloudxLab, from the CloudxLab perspective, since we do not guarantee the confidentiality of the data because our dev engineers would take a look at it. Second, the kind of guarantee you would need with respect to the enterprise deployment would actually something that would hurt our educational users. Therefore, we generally avoid doing the enterprise deployment in this. In case we have to do something for production, we generally launch separate cluster or separate machines for that. Okay, so all right. So that is one thing. So we generally, what we do generally is we generally launch a separate cluster if somebody is asking for one. Okay. All right. So great, great. Very good question. So let's move ahead. All right. So today we are going to discuss another feature of Hive called partitions. What does partitions do in Hive? Imagine that you have a table. Imagine that you have a table with, say, 3 columns: first name, department, and year of joining. And let's say this data is in two folders. Let me show you. So you can see that inside data BDHS employees on HDFS, okay, it is there. So I'm going to directly go into Hue and take a look at that folder. Take a look at that folder. So you could just click on File Browser and go to the top level and say data and BDHS and employees. So you have these two files, correct? You have two files. One is 2012, other is 2015. So this one contains the name of the employee, the the team of the employee, and the date of joining. Similarly, we have two files. Now this one is for the people who joined in 2012. This one is for the people who joined in 2015. Now, let's say, and it's a classic issue with most of the systems that every year, we generally every year, every month, or every week, what we keep on doing is we keep on archiving our data to a remote location, or we keep on archiving it to maybe AWS and so on. So it's a common issue. So to overcome that kind of issue, Hive provides partitions. Okay, instead of creating so many tables, you could create just one table, and then you could create these columns based on each files, right? There are two ways to look at the data. Either we look at two files at two separate tables, and then we kind of union them or join them. That is one way to look at it. Or what we could do is we could just look at them, look at these two files. If they are exactly of the same file format, we could look at the two files as if they are a single table, just that one column entry is different. So when we create a partition table out of these files, the partition table will have 4 columns, 3 these columns, and fourth one will be the name of this file, which will be fourth column will be having the value called 2012 and 2015. Let me show you this. So what we're going to do is, first of all, from the common place, which is the common place here, we'll copy this data to our home directory just the way we did earlier, and then we're going to create a table called employees, and then we will define name, department, and then we'll just say some date, and this is our table that we're creating. Afterwards, so first thing we're going to do is we are going to copy this data, these two files, into our home directory. Second, we are going to do is we're going to create this table. This table says the data is terminated by comma. As you can see that the data was actually comma separated. And then we will load first file, second file. And please notice that we are saying here that this table that we are creating is partitioned by one more fourth column called year. So this column we will be specifying manually while loading. So these 3 columns are coming from the file, and this column is coming from our hard coded or is provided by us. Let's take a look. So here we have we have this 2012 file. We are loading that one into the table employees, and then we are saying partition by this. So we are providing the value for a partition called year, and this partition we defined here. Okay. All right, so this is what we are going to do. We are going to load 2 partitions into the table and specify the name of 4th column manually, because these files have only 3 columns. Okay, so you can see that. Now let's try to execute this. First of all, we're going to copy this employees folder. All of you, are you ready? So you open file browser, go to data, go to BDHS, select employees folder, copy it to your home directory. Okay, I'm going to click on home. Or if you are not comfortable, you just take a look at it now and you can do it maybe at later point of time. So right now we just copied this folder into our home directory. Let me just show you. Okay, so here is the folder that we have created. Good. And you can also take a look at these files. You have just 3 rows here, 3 rows here. Okay, wonderful. Now the next thing we're going to do is we're going to create this table. All right, how do we go about it? We go to the query editor. Okay, use the same database that we used yesterday. Remember this database. Okay, so we are going to say create table. Okay, and I'll have to copy this. Okay, I'll also give you this folder, this to all of you. Okay, and here we go. So what we did was we created a table called employees with a column name this, department this, some date this. All right, and we said that our data would be comma separated. All right, so here we go. Let's say Let's see if we get some error. Oh, all right. So we could also take a look at this table, select star from employees, right? So we could just take a look at this one if it has been created. Looks like it has been created, or we could also say describe employee just to understand what's going on there. Okay, so the table has been created. Now the next thing we're going to do is we're going to call the load statement. We're going to load first file 2012 CSV into our table called employees, and we're going to specify a partition. All right, please pay attention to the partition part, because we have defined this table as partition table, and the fourth column, which is the basis for the partition, is the year. It is manually specified column. So while these three columns will be coming from the files data, the fourth one will be specifying manually. Okay, I think Oracle already has a similar mechanism. Okay, sure, I'll just give you whatever I have written here. You'll have to change the name of the database as well as name of the login name. Okay, so here we have put the data into our table. Okay, now let's take a look at the table, right? Let's take a look at the table, select star from employees. Okay, so you will notice that it has it has created a table which you can query with 4 columns. These 3 columns came from the data, while all of the records in the fourth column have the same value 2012. Does it make sense to all of you? Now, in the similar way, we're going to load data of 2015.csv into this. A question from Binta is, why cannot I see employees table in my database? Okay, probably while creating the database, either you did not specify use, okay, or you did not select the database here, either of the two. A question from David is, what is the command to find out what database I'm connected to? You can just say show space tables, and if those tables look like yours, then you can see that. And I think there would be a command to show the current database. Okay, show current database. There should be a command in Hive. Okay, all right. There is a way to show on the command prompt. Command prompt does show you the current database, but I'm not sure about you. Okay, so there should be show current database in Hive using a query instead of the prompt. All right, so there should be something there. Okay, generally when we do this, it should show you. And okay, there should be some better way. All right, so a question is, question from Bintao is, my employees table is empty. Did this work for you? No. A question from Hitendra is, how is the partition column year getting value from? We are setting its value here, okay, while loading the data. All right. Binda, do you want to show the screen? Should I stop sharing the screen? All right. Go ahead. Okay, good. Did you load the database?
Not yet. Maybe I need to load my database first.
Okay. You have to copy the data. Yeah.
Okay, maybe from here.
Yes. Did you copy employees table to your home directory?
Yes, I think so.
Okay, wonderful. Good. Now try just clicking on that I in front of the table. That should also work.
Let me try selector.
Yeah.
Selector.
Okay, there is a L missing after that. Just select that particular line. Okay. Yeah. Yeah. Now run.
Okay, good.
All right. Good. Wonderful. Wonderful. Okay. So yes. All right. Okay. A question from Subbu is, can you tell me once from where should I copy the employees data? It is inside /data/bdhs. Okay. If you take a look at here, if you go to file browser, you will see /data and here you'll see bdhs and then you'll see employees. So you just have to copy the employees folder into your home directory, then run the load command, and that should be good enough. Okay.
Sandeep, I
Yes,
cannot
go ahead.
load data into the table actually.
Okay, could you show me? Yeah. Yes, go ahead, Hitendra.
So this is what I am executing.
Okay.
And then
Again,
why we are not selecting, we are not putting BDHS. The directory structure is like BDHS under that.
no, did you copy that /data/bdhs here?
Yes, it's in my.
Okay, good, good. Oh, you copied the BDHS folder. Ah, your observation is right. Then you should put BDHS in that. Yeah, your observation is right. Good. Because you were basically copying only the employees folder. Okay. Now try doing the same thing, running the 2627. Okay.
You want me to select the
2627. Just run it.
Yeah, this is what I'm
Just let me take a look at this. Okay. Can you just try deleting these codes and writing again the codes? I'm always very skeptic about the single quote. Just before HDFS, you have the single quote. Yeah, change that also and the other one also. Okay. All right. Now select the two lines, 29, 23, 29 and 30 and run it. Okay, looks like it did not work.
Yeah.
All right.
The table is existing though.
Can I take a look at this? Could you show me okay, could you show me override into employees, EMPLOYEES. This is correct only, right? No, employees, right? That's correct only, right?
Yeah, it's the same.
Partition year equals this. I think this is right only. Okay, load data in path. Use, all right. Okay, so could you show me the folder in your home directory where you copied this? Okay, refresh it. Okay, let's try again.
This is right? I mean, is this correct? 3 front slashes.
Yeah. So first two slashes are for the protocol, and this next slash is for the absolute path. Okay, and that's correct. And I'm just wondering what's wrong with this one. Load data in path, use GC underscore 20 March
Hello, Sandeep.
18. Yes,
This override keyword is there because of
right.
your
You are right. You are right. A good. It's a very good observation. Right. Thank you. Thank you. Is that no?
yeah.
Okay. Yeah. Thank you. All right. Could you remove this override and then try again? Probably in the partition, you cannot override.
Okay, I
Okay.
just copied my yesterday's comment. Yeah, because
Into
for particulars,
you have to say into table. Okay. Into table.
load data.
After load data in path, that was correct.
Okay.
In path and then into table. Okay. And I think this should work. Now this is working. I think there were those two mistakes. One was into table, other was the, okay, great, wonderful. All right. So great to do the hands-on.
Sandeep, can you tell
Yeah.
me from where we need to copy the file?
Okay. So first of all, copy the file from /data/bdhs. Do you want to do the hands-on again?
Yeah.
All right. Probably others will also be doing parallelly. So I think by the time you finish, others will also be finishing. So please go ahead. Okay. So go to /data/bdhs. Go up the first one from little down. Yeah, little down. Yes, that's the one. Okay. Just select the folder, as in put the checkbox. Actions. Then click on home. Click on home at the top. Yes. Click on copy. Okay, now let's go. Open one more Hughes, this thing. All right, yeah. Go to say Hive using query editors and Hive. Okay, you have created a database, right? Test AC.
Yes.
Good. Now let's use again. We will create the table what I gave you.
This I will delete.
Yes, delete it. Okay, so good that you have copied it. All right. Okay, so first of all, we'll be not this one. Go down. Today's one.
This one.
Yes. Okay.
Yeah.
Right. So yes, today we are creating the partition table. So that's why there is a clause called partition by. Now select. Yeah, you can delete this one also. Yeah. Okay. Now select everything and execute. Okay, so table must have been created. Now you can try saying use, just copy the first line again here. Yeah, and say describe table employees. Okay, describe space table employees. Okay. While in the meantime, those who are trying to do hands-on, they can also try at the same time. Okay, just select only 12 and 13 line, please. Yeah, because. Okay. Question from David is, have him set the database dropdown. Actually, the problem is the people whose name starts with something really back, it doesn't show up those databases. Therefore, okay, this is good. Now let's okay, again copy the use statement in the next line. Yeah. Okay. All right, not like that, not like that, not like that. So you have to select a particular statement because that table is already existing. Okay, so now what we have to do is, now you have created the table. Now is the time to load the data in the table. So copy that load data statement. Yeah, that's the one. That's the one. Yes. Okay, change the login to yours. Change the login to yours. Change, instead of Sandeep Giri, write Sachin Sikri 239576. Good. So what we are doing right now, we are loading data into the table we created above. Okay, select 14 and 15th line only, otherwise it will try to execute everything again. Okay, click on execute. All right, now it must have loaded the data. Now let's write once more, use this. Okay, yeah. Okay, wonderful. Say enter and say select star from your table. Enter, select star from employees. Good. Select only 16 and 17 line and run that. All right. So it should work. It did not work. Okay. Anybody? Try HDFS : / this into the table. Can you just go to your home directory and check if employees file is there? In the second hue, click on home. Click on home. Let's see if the copying was successful or not. Yeah, there is employees. Click on employees. This is the file that we are trying to load. Okay, let's go back. Okay, anybody who can pinpoint the error? Maybe you can delete that single quote before HDFS and type this again. The single quote, yeah. Okay, into this table and then again. The second one also, yeah. Yeah, now select 14 and 15th line and try it again. I'm hoping that it should work. Load data in path this, search in 2395756. Oh, there is one extra 5 there in the login. Okay, now select only 14 and 15 and run it again. Okay, now it has run. 16 and 17, select and run. Wonderful. So you are able to run it.
So what is doing? It is and loading the .csv file from the 2000 employee 2012
Yes.
here.
Yes. So we will
And
add one. Yeah.
On the table, we have uploaded the file, uploaded the content. On the employees table, we uploaded the content.
Correct.
Correct. Okay.
Okay.
Thanks.
All right. Wonderful. So we're going ahead and here. All right. So this is what we did. Now is the time to run the second command. Okay. So here we are saying load data in path. Now this time we are loading 2015 file and we are specifying the value of the fourth column manually here in the end. Okay. So now again, let me just run my select star query and it should be like this. All right. So you can see that it has created a single table. It has created a single table out of multiple files. These files could be such that they're existing in completely different folders, they're existing on completely different locations. Still, you could create the partitions. Okay, so this is an interesting concept that you merge multiple files into a single table, though these files will exist as if they are separate files, but they will be presented to you as a table. Now, one more important thing that I would like to bring to you is that when you do things like select star from employees, now you can basically select based on the year also. Okay, say I'm saying give me all the employees where the year is 2015 or year is greater than 2012. Year is greater than 2012. Okay, so you can see that it would give us only the results. Select star from employees where year equals to, let me just see if this works or not. Oh, I've not selected the database. Okay, not this. I'll have to use the use statement and then do that. Okay, now we could either execute a query like this. You can see that we were able to just select the data from the second file, and we could say greater than 12 or greater than 13. Those kind of queries also we can execute. Now, what's the important part here? That while we are executing this query, the second one, this query is far more efficient than the previous query, which was in the line number 19. Okay, this query is far more efficient than this query. Why is this query efficient? Because this query only reads one file, 2015. It does not read 2012. Okay, that's one of the very important roles of partitions, that it does not load the data. It does the pre-processing of your query and figures out which of the columns are from the partition, and hence which of the files can be ignored even before executing the query. So this is a big utility of this. Okay, all right. Question, Bintal, you have a question regarding the basic steps? All right, question from Gaurav is, why do I see 9 columns when I say describe the table? Maybe you are describing some other table. Are you describing NYSE or something? Okay, let me just see if I could. Okay, so yeah, so this is not a column actually. It's just some extra information. Okay, probably these are the only columns from here till here. These are not the columns. These are some extra information. Okay. Good observation, Hitendra. Now coming to Robin's question, I'm curious at query editors, the recent queries tab is getting full. Is there a way to clear it? I'm not sure. There could be something there. All right, there would be something, download the results and things like that. Okay, I think the older queries will keep on getting cleared. A question from Hitendra, if we run line number 12 and 13, then what will happen? 12 and 13, I think it will add one more partition in the data. You mean this line, this one, 22 and 23. If you do that, then it'll basically add one more partition with this data again. That's what my understanding is. Okay, so now you can see that the records will be duplicated, I think. No, actually it overwrote the partition. It actually overwrote the partition. So in case of partitions, Hive basically overwrites the data, overwrites the partition. All right. So a question from Sachin is, how do you relate Hive partitions here? So we basically created one partition column extra, and while adding the data, we specified the value of that partition, value of that column explicitly, and that essentially marked that this data is coming from this file, this particular value, and so on. Okay, great, great. A question from Robin is, what program or script did you use to create table? Where this one? So I wrote this thing manually. All right. It's a standard table definition, just that these two extra information is what we have to specify. Okay. All right. Is that your question? Wonderful. So we were able to load partitions and do that. A question from Hitendra is, I was not able to save query results to Unix using insert overwrite local directory. Did not work every time. The single code is getting changed to. So I think what you need to do is maybe open Notepad, change the single quote manually to the normal single quote, and then copy paste. Okay, that generally works for me. All right, good, wonderful, wonderful that we were able to do hands-on. So let me just explain what happened here. I hope you all got the idea about what happened. Now, let me just give you what we learned here in partition. So to avoid the full table scan, when we are querying the data, let's say you have a table of last 50 years of data in your organization, and you only need a small window of data at a time. So, and this table, this 50 years data could be in 5,000 files. So what you could do is you could just take a look at the partitions and create your load data script, either using regular expressions or using manually, and create a single table out of all of this data, and once you have a single table, then you can easily query whichever data you want. But if you are having just too much data in your Hive table, it's definitely possible to have too much data in your Hive table. So, and you want to avoid time-consuming queries, so you must create the partitions. This would help you avoiding the full table scan. Full table scan means multiple files scanned. The data is stored in different files in warehouse defined by the partitions. Then you can, when you define the partitions using partition by in the create table, that's what you do to define the partitions. And we can also add partitions later. If let's say, this is Hive session only, Prashant. Yes, Hive is nothing but a SQL engine. So it's more like SQL session. All right. So what we are trying to do is we are creating tables in Hive and then adding data into the table and querying it. Okay, the data is getting created in HDFS and queries are being executed via MapReduce. Okay, so that's what Hive is doing under the hood. For us, it's just a very clean thing. Okay, so for us, it's just a clean thing that we can create table, load data, and query. But under the hood, it's doing the MapReduce and everything for us. Okay, this is the most practical way of doing the data processing if our data is structured. Okay, we can also add partitions later. Okay, and we can partition also. A very important part is, let's say, the partitions can also happen on multiple columns. Instead of year, let's say you have monthly data, right? So you could have even daily data. Let's say you have every day's data is few gigabytes, correct? So and then your files are per day basis. So you could basically create 3 more columns: year, month, and day. And while adding the partition, while creating the partition, you could say create partition by year equals to this. Create partition, so we can say create table, and then in the partition by we could use multiple columns, and while adding the data we could actually specify multiple values for this column. Okay, so and also we can do many things on the partitions. Now we will start with the Hive views. All right. Okay, a question from Prasant is point from Prasant is that Hive does not support transactions, so we can't compare it to the RDBMS. That's right. Hive adds extension to provide better support in context of Hadoop and to integrate with custom extensions and even external programs. That's correct. It is well suited for this. Correct. Going ahead. So a question from Robin that how can we verify the syntax of parameters that okay, so I think you should just take a look at the presentation here, or even the self-paced course that you have access to. Just take a look at that one. I think that'll clear your doubts. The most important part would be to do a bit of hands-on. And this is, I would strongly recommend everybody to be hands-on with Hive, because most of the time you are going to spend with Hive if you are in Hadoop world. Okay, so yes, that's why we did multiple hands-on for this session. Okay, and most of it is just standard querying. The only challenge that we saw with many people is challenge with where is my data, where is my folder, how to load this data, how to load this, how to load that. So it's basically a hands-on problem with Hive, nothing else. That's why you must try the Hive by yourself. Okay. A question from Robin, how can we verify the syntax of parameters that we input to query editor, such as this? Okay. I think, yes, it's a very valid question that the query editor doesn't give us proper error. So you could just copy paste in the console. All right. There was a question from Bintao. What is the name of partition by year string row format terminated by comma in a query? What is a name of, okay, how many kinds of it are there? Let me just understand again. What is the name of partition by year string? Okay. All right. In a query, how many kinds of it are there? Okay, so we basically created a partitioned column called year, and you could add more columns here, but partition by year, month, and so on. Okay, here the data type of year was string. You could have a similar thing with integer as well. Okay, and so on. Okay, or did we have a different? Yeah, it was string here, but we should have used integer. That could have been easier. Okay. Could you? I see. Do you mean that the row format delimited fields, there could be many kind of row format, right? One is delimited fields, fixed file format, and so on, right? There are many kinds of it. Okay. And one must consult the documentation of Hive to see that. We will also talk about a couple of more formats. Okay. Going forward. Question from Gaurav is, can we have subpartitions? Yes, this is what we call about subpartitions, basically partitions on multiple columns. Okay. A question from Noor is, I didn't get the multiple column partition. So what we just did was we created partitions with extra column values, right? With extra column values. While loading the data, we specified extra column values. In the same way, we could also add extra multiple columns instead of only year. Okay, that's the idea. All right. Question from Noor is how are actual files named? Take a look at that. It basically for every column it creates a hierarchical folder structure. Okay. So it'll basically create one folder name called year equals 2012, and then another one will be month equals 10 inside year one, and so on. So whatever partitions we keep on adding, it'll keep on creating the hierarchical folder structure of one partition inside another. Okay, so take a look at it. Okay, so in single column partition, partition by value is matching to the file name, but how the file would be named for multiple column partitions. Okay, I'll show you. So what has happened here, if you go here in the file browser, click on not home, you click on say slash, click on warehouse apps, then warehouse. Okay, where is the Hive? Then warehouse. Then here you could have sg underscore this one. Okay. All right, I'll have to delete whatever was there in this. Now employees was a partition. You can see that here it has created a folder with the name year equals 2012, year equals 2015. Had we had like month-based column, month-based system, it could have created one more folder here saying month equals 12, month equals 15, and so on, right? So for every partition, it keeps on creating the hierarchical structure. All right, you could give it a shot. Okay, so good. Question from Hitendra with the Spark, is it possible to avoid using Hive? So the thing is, the truth is, the mechanism of creating tables, creating databases will remain as such even with Spark SQL. So even if you don't use Hive for that, the mechanism will remain the same. Okay, because Spark uses the Hive's engine for reading and loading the metadata. Okay, that is reading the file description, understanding the file structure, and so on. Okay, so Spark SQL does that. So whatever we are learning here is true for Spark SQL's tables as well as Hive's tables. Further question is Spark SQL is Hive under the hood? No, actually. Hive has something called catalog service, catalog service. That catalog service is the one which maintains the metadata and metastore. So that particular metastore service is what is being utilized by Spark SQL, not the entire Hive. Okay, so there are two parts of Spark SQL. One, it basically does the direct querying of the data. Other is it loads the metadata from the same place where Hive is located. So Spark SQL does that. Question from Sachin is load path in path will upload data from HDFS into Hive. Correct. But Hive's data is also in Hive's warehouse is also in the HDFS. So it'll basically move from your HDFS folder into Hive's warehouse folder. You can just check the table that you copied, the file that you copied in your home drive must have disappeared. And if you go to warehouse, you will notice the same file there inside your database, inside your table. Okay. Question from Bintao is what's the structure? What is the syntax for? Let me just read the question from. Okay. Okay. Do you mean to say that for multiple columns, how will this structure look like? Is that your question? Okay. All right, let's just spend a bit of time. So what I'm going to do is I'm going to drop this employees table. Okay. So I'm going to just copy this here. and say drop table, okay, and I'm going to say employees. All right, so here we go. What did it do? Okay, I just check if it is still there. Table not found. Good, the table is deleted. Now I'll have to again copy the data. All right, I'll have to again copy the data. Let me just copy the data. Okay, so I've copied this central data to my home drive just to make sure that I don't touch the central database, central file storage. Now we are saying here that create this. Now this time, instead of year, I'm saying month, and we call it integer. Okay, and let's say this one also we're going to call integer. So here we are saying in this database, create this table with two columns. One is year, other is month. Okay, what it says is could not find this operation handle. Why is that?
Sandeep, where we can see the Hive data app warehouse.
App Hive warehouse
Yeah.
slash
Correct.
apps slash Hive slash warehouse.
And then
Then inside that you will have your own database name. Go into that folder with your database name, and there you will see the folders for each table.
yeah, actually there's a with different user. I'm not able to find with my user.
I did not know. See, with your user, no, just search for test underscore your database name.
Okay.
So inside the warehouse, you will have your folder with the name as database. Okay.
Okay. And under my database.
Yes.
Yeah, under my database is not there.
Just remove, there is a text box. In case you search for your database, the text box will still contain your query, and that could be stopping the editor. Is that?
Oh, it is not there.
As in?
Yeah,
Can
it
you
is. Yeah.
can you show the screen?
Yeah, I am able to find it. Thanks.
Okay, great.
So
All
file
right.
complete CSV is uploaded into the.
Yes, correct. Basically, it's just moved.
Okay.
Okay. Yes. So what we are doing is we are creating this. How can I just? All right, I'll just wait for it to load. I'll just refresh the screen because. Okay, can I just remove this? Okay, let me just try to do this again. All right, so I'll say select this and describe employees. Okay. It says could not find, I don't know what's wrong with this. Could not find log associated with operations. Okay, is the table not existing or what's wrong with this? Now I'll just try again if this works. Is it wrong?
Sandeep, I think
Yes.
your parameter data type was string, I think. Is that the reason?
No, actually this says that employee table already exists. Okay, no worries. So I'll just try to create this.
Are you missing semicolon?
No, actually, it's a single query.
No, after drop table.
Maybe that could be an issue. So it says, just a second. So if it was a table, so it should be there. It must have created the folder there. I could say, describe this. It says, I cannot find log associated with the operation handle. Is there something here which I'm missing? Okay, just a second. So one of the doubt is that can I have this and this? Let me just see if it is working. Now this time it'll say the table already exists. Okay, and when I say describe, it is not showing this. It is not saying this. So let me see if I could just execute this and see the output. All right. So this is just the original query, right? Something is wrong with this database. I'll have to restart it or something.
So
Okay.
even I'm getting the same error like you.
Okay. So I'll just see if I can restart. I think there's something wrong with this database. I'll just restart the Hive once. Probably that will solve the problems. Okay. So there is Hive server 2 and Hive server 1. So I'm going to restart Hive server 2. Okay. Okay, I've restarted both the Hive servers. All right, let me just see if we can take a look at this table again and see what is going on there. And can I just try show tables here? It has employees, right? It has employees. And when I say describe table, describe formatted employees. Now it is working fine. Okay, so again, I'll just go back where we were. All right, and I'm going to, so you can see there is name, year, and month. These are the two partitions, basically. These are two partitions we just created. And the data type of these partitions was int. So this command int and month int worked. Okay, this has already worked, just that there was something wrong with the servers. So, and now we are saying that we are loading data into this and saying month equals, say, 10. Okay, so this time we are saying month equals 10. All right, now you're going to see that the data looks like this. See that? So you have employee here, month equals 10. And in this one, let's say we have month equals 11, right? All right, so you can see that this table contains how many columns now? 3 plus 2. These two are coming from partitions, and these 3 are coming from the actual data. All right, so I can give you these commands. Okay, so I think this is very good. Now, If you take a look at the underlying data, what's happening there in the underlying data? Okay, let me just go back to apps and say Hive, and we say warehouse, and let me just locate my folder. You can see this folder, and let me just remove from text box. And here, what you see is the employees. So you can see that at the top level, you have two folders. Years equals 2000, year equals this, year equals this. Inside this, there is one more level of folders, month equals 10. Okay, so it creates the hierarchical structure like this. Make sense to you? Great, great. You must give it a try, and that should be good. Wonderful. Now, so partition can happen on multiple columns. That's what we just did in the lab. Okay, you must give it a try. Now, the next concept in Hive, which is very, very important, is views. So question from Hitendra, before I move forward. Question from Hitendra is, so partition values have to be specified in the load statement for every file that goes into Hive. That's right. A question from Rajan is, so what happens if I need to move data in the partition? What happens if need to move the data in the partition? Okay, let's say you're moving data into the partition. So when you are loading data into the partition, if it's a managed table, the data will be moved there. If it's an external table, then data will just be linked. Okay, the actual data will not move. A question from Rajan is that, for example, let us say that joining date is 2015 and I want to change it to 2016 after partition. That is something actually Hive, though Hive says that they allow editing, but I'm not sure what would happen in that case. Okay, Hive never allowed the modification of this particular column, and maybe on the partitions columns, I would say that it would not allow. The easier one will be to just remove the partition, add the partition again, or load the data again in 2016. That should be better. Okay. All right, great. A further question is from Sachin. So in real time, file data is also in HDFS and Hive data is also in the HDFS, correct? In most of the cases, that's why we call HDFS as data lake, in which the data from everywhere is there, and Hive data is also there, HDFS is also there, and HBase is also there. Though there are ways to connect Hive to the external systems, but this is the most common use case. All right, great. So the next idea is views. So what we observed is that every time we are querying a table, we have to write the whole SQL. Okay. So for those kind of cases, views are very, very important. So what we do is, instead of creating a new table, what we do is we give a name to our query. So views are nothing but we create a name for the query, just like we create stored procedures. Sorry, just like the way we create functions in a programming language. In the same way, we can give name to a piece of code, right? What is a function in the programming languages? The function in a programming language is nothing but bunch of code which we have given a name, which can take an argument and so on, right? Similarly, we could create a view over bunch of SQLs and give it a name like this. Say, for example, here we are creating a view called employees_engineering as this, which means that we are creating a view employees_engineering here, and then we can write the query on top of it. Let's say I'm going to give you these queries. Okay. So if you need to execute this query very often, we could easily, okay, we could easily create an alias for this full query, this query from here to there, and then we can do further work on this. Okay, we could do further work on this where year equals 2012. Okay, so we can create a view like this. Okay, we could create the view like this, and we could execute this query on top of that. All right, so let me just first try to execute this here. Let me increase my window. So what happened here? Yeah, this is where we were trying to tweak it. Okay, let me copy the use statement because that's what you're going to use. Okay, so we've just created a view called this, and then all right, then again I'm saying use, and this time I'm executing this particular query. All right, so these are the two things that we are trying to do. Okay, put the semicolon, don't forget the semicolon. Select star from employees, and then was there a mistake here? I said here we created a view, use this, create view, employees, this, and here, let me try again. All right, I'm going to just refresh this window. This editor is not as sophisticated as the corresponding editors of any relational database. Maybe the newer versions, they have upgraded some things. All right.
Sandeep, I have a question here. I mean, it's not related to what you're doing. Once we insert
Okay.
data into a table from the file, right, will the file get lost?
Will file get what?
Lost? Will they get lost automatically once we insert data into the table from the file?
When it will be deleted. Your source file will be moved. Okay.
You mean once the insertion happens, right?
Yeah. Yeah.
Okay.
Just like when we drag and drop the data. Okay. Just like we drag and drop the data from in Windows. Just like that, when we move there, when we drag and drop in Windows, the file moves, your folder moves in the same drive. In the same way, HDFS also basically, Hive also move the data instead of copying it, because data is already like replicated 3 times, and data is generally big. So yeah, so this is how you generally call this. The error was that I was saying select employees engineering instead of saying standard query. So here you're not able to differentiate whether this is a view or a table. Correct? And that's exactly the role of a view. A lot of complexity can be abstracted out by the way of using the views. A lot of complexity can be overcome by the way of using views. Okay, so that way. All right, so that was example of using Hive. Okay. All right. Yes, a point from David is that generally when creating a view, it is prefixed with VW underscore table name. Yes, that's right. So it's kind of, you know that it's view. You are basically giving it a distinctive name. All right. So the idea is very simple very simple as the normal SQLs that when you so I very well remember in one of the projects at Beach long back around 10 years ago, not 10, as in 12 years ago, when we were doing this reconcilers and we were writing these queries, at that time, we were just using Postgres and we had like really humongous data at that point of time. So at that point of time, whenever we were trying to write the queries, so queries were becoming really big. So in order to abstract out a lot of queries, we were writing views so that whenever required, we could reuse the views at multiple places. So if you have like so many queries and you see that there's a common code that could be common query that could be abstracted out, you just create a view out of it and use the view instead of that particular query. That simplifies a lot of logic. It also makes life really easy for you. Say, for example, you're grouping the data. After grouping, what you want to do is you want to filter after grouping, right? So if you create a view on top of the group data, then you can just query the view just like anything else. Now, so this is what we learned. Views allow a query to be saved and treated like a table. It's a logical construct. It does not store data. It hides the query complexity, divides long and complicated query into small and manageable pieces of code, pieces of SQL, similar to writing a function in a programming language. Okay. The other part is that in Hive, you could load very complex data. See, comma separated data we all loaded. If you, let's say, want to load a complex data like JSON, you could simply say add jar. This you can try, add jar and create your table, and that's how. You could create table with various columns and so on, and it will automatically create the table. And when we are loading data, it'll basically consider the data to be in the JSON format. Okay. So this is how you generally load JSON format. So all you need to do is in the same Hive session, you need to say add jar this. It'll load this particular jar. Okay, this is a custom program to convert the underlying data into records. That's what is called SER. SER means serializer. DE represents deserializer. So if you have this custom data and you might have to write your SERDAY as in serializer, deserializer, but for most of the formats on the internet, you already have the serializer, deserializer. We are using the serializer, JSON serializer from an open source project. Here, we have already downloaded it for you and kept it at this location in HDFS. So when you say add space jar and then provide this jar, this basically jar get registered. And when we are saying this time, instead of saying row format delimited, we are saying row format is SERDAY, meaning this class will convert the raw data in the file into the records, right? So while we execute a select query on this table, this class, this program, this piece of logic is going to be consulted, this program of this piece of code is going to be executed on this raw data, and convert into the table. Okay, convert into the table. JSON is the standard JSON format, and this is the example that you'll see in the project, in the sample project which we have given you related to the. Okay, question from Bintao is how to create such a jar file. Okay, how to create such a jar file. Basically, the way you create it, by implementing a particular class called Saturday in Hive, and then you write your own program to convert the raw data into records. Okay. So yes, you could take a look at the source code of the JSON Saturday. That will give you a very better picture. Okay. And but for most of the formats, you would be able to get the open source libraries for the serialization, deserialization. Okay. All right. All right. Yes. JSON is very similar to XML. So we have XML Saturday, we have JSON Saturday, and we have many other formats for which the serializer, deserializer is available. Okay. So a question from David is, in the Hive, how do you know the query that view represents? Just run describe formatted over the view, and in the description you will find the underlying query. Okay, so JSON is a collection of key value pairs where each value could again be another object and so on. So that's how the JSON is. Okay, all right. So that's our. Let's just take a break here, and we'll be back soon. Break for 10 minutes, and back by 9:47 p.m. IST. A question was in Hive, how do you access the query the view is representing? All right, we will give that. Sure. Okay. Describe does not show. All right. There was one question from Noor related to this. Okay. Okay. So let's take a look at it. So first question is, all right. So I'm back. Should we start? All right. The Hive's Handson, the specifically the JSON one, you must give it a try with Hive project. In the Hive project, you will try loading the data using that JSON serializer. So you will figure that out when you work on that. Okay. So that part we had left so that you could do it using during the hands-on. Okay. In Hive, question is in Hive, how do you access the query the view is representing? So let me just see if we could. Okay, so our view was this. Show, or let me say, describe formatted this. Okay. So you can see that the view explained in the text. All right, you could take a look at that. This was the original. This was the original one. Okay, and this is the expanded text in the detailed. All right, good question. So you could use describe formatted in order to get the details about the view. Okay, so generally describe formatted gives you more details about everything than usual describe. So you could use that in order to take a look. All right, so can we see the view on the left-hand side object? I'm not sure about that. I think you should be able to see that. Okay, I think those Bintao can tell you because Bintao has the database listed on that side. Okay, so for me, it's not listed, so I can't really tell. Okay, now, All right. So with respect to the JSON survey, the JSON is nothing but key value pairs where the value can be further another key value pairs, and those are on the curly brackets. Okay, those are on the curly brackets. And so the JSON data, I'll show you, or should I show you now? If you take a look at this particular example, if you go to say CloudxLab here, if you go to CloudxLab here and then go to say here, let's say go to my courses, or then just search Hive project. So here you will see that there is some data here. Then there is this query here. Okay, there is a query here. And if you go to the, let's say, sentiment analysis step number 1, where you basically have to copy this data into your home directory. Now, here is an example. This data that is located at this place. Okay, sorry, where was the tweets raw data located? Tweets raw data is located in /data/sentiment files. Okay, I'm going to show you where is that data located. So /data/sentiment files. Inside this again, if you go into the upload folder, okay, then you will have this data, and this is the tweets raw data, and these files are zipped. So whenever you are using the uh, sorry, whenever you're using the HDFS and these libraries automatically uncompress the data if that is in the gzip compression. Now I'm going to show you that these are basically the tweets of users. You know what is tweet? When you are using Twitter, you have individual messages as the tweet. So this is the data is in the JSON format. Every line of the text is a complete JSON object. So to format it better, we could use an online tool called JSON Formatter. So this is how the data looks like. Okay, so you can see here that this data is in this format. There's a key, there's a value. There's a key, there's a value. The text of the tweet is this, while the contributors are null, filter label is this, geographical attributes are these, and here there's a further complex data. It says URLs are these. So you can see the key value, JSON, is represented by curly brackets till the end. Okay, it starts with curly bracket, ends with curly bracket, and has key value pairs around it. And inside, the values of any of these could be further, complex object. Okay, so the value could be further another object of key value pairs. Okay, so this is how the JSON object looks like. JSON is a general format. It's basically started with JavaScript object notation, but as of today, JSON is JSON is a very user-friendly and popular format to represent complex data. It is more efficient than XML because you just have to put curly brackets instead of start tag and tag. Okay, so you can see that this is the kind of JSON that we're talking about. And to load this JSON, if you go back to this Hive project, you will see the command how to load it. Okay. Where did it go? Hive project sentiment analysis. Let me just go back to the step number 2. So here you see the first thing that we need to do is add jar. Second thing, let me hide this terminal for some time. Okay. Second thing that you see here is creating a database. Then we are creating this huge table and we are loading data using JSON survey. Okay, where did this class come from? This class will come from adding this jar. Okay, and so on. So give it a try. There are extra parameters that we have put in. Okay. All right, so let's just give you this chat command. You should take a look at it. I'm just giving you the URL of the entire thing, and that should be better. All right, so this project will basically walk you through the entire sentiment analysis. So you must attempt this project. Okay, it's a very, very important to do this project, and doing it in the class will not be efficient because it would take you to through many steps. Now, where is the project? You could always go to, say, my courses. Yeah, you can start project just after now. Now, when you click on My Projects, under the My Projects, you will, let's say, go to this big data with Hadoop and Spark. This would be given to all of you. It has complete course recorded in the studio, as well as all the exercises. All of the exercises should show 100% here. Okay, you should go through the entire exercises. Do not skip any of the exercises. And except for, you can skip Java Essentials, you can skip MapReduce programming, and you can skip Pig and Pig Latin. Okay, and then this Hive project. So you have to attempt this one, and that's how you will get the hands-on experience. Good. Now, a question from Noor was that this is not intuitive at all. How is it being used in production? Like for simple queries, it is giving headache. Then how people would be able to create complex query? Is it being used in production, or it is being used in production, just as this hue, the web interface, is giving us a bit of problem. Okay, so it is being used in the production and the queries do work very well. It is just that the editor is not showing proper error. That's why we were not comfortable with it. Otherwise, it's actually being used by many people for querying a lot of data. All right, so good. All right, so this is what we talked about. The other part of the Hive is sorting and distribute by. This is a bit of theory. So the essence is when we are using order by, it'll only reuse internally. It'll use MapReduce, correct? And in MapReduce, there could be one reducer or many reducers. By default, order by will have single reducer. Okay. Therefore, it is not acceptable for large data sets. Okay. A question from Hitendra is, how do we know if add jar worked in Hive query editor or not? It should give an error if it worked. It did not work. Okay, just give it a try. You will know, you will get the idea. Okay. A question from Noor is, can I use my Twitter file? It'll work. Yes, it should work. Okay. Then if the file that you're using is in the proper JSON format. A question from Rajan is that, is Hive primarily used by data scientists to query the data and produce results, or is there a programming interface to Hive that we can connect from Java and execute query? That's correct, that you can do that. You can actually, so Hive is used by everyone. Hive is used by data analysts. Hive is used by data scientists. The Hive is used by data engineers, and Hive is also used by people who are just looking at business analytics from the visual analytics perspective. So Hive is used by everybody. All right. So now the order by is not efficient at all, because if your data is big, then it is going to go through one reducer. Therefore, they invented sort by X, and that wasn't, again, it was basically splitting the data into multiple ones, and it was not giving good results. It's like having multiple reducers and having multiple files. Therefore, so if you have two reducers, one reducer is giving Aaron and Bain, and other reducers output will be Adam and Barbara, even though the output of the two reducers is good, is in the order, this one and this one. But when both of these get concatenated, you always get this unordered file, right? Therefore, sort by X, which was basically using n number of reducers, and it was basically creating this kind of format. Therefore, it was not acceptable. Therefore, idea of distribute by X came in picture, whereby we have n reducers. In summary, the idea is to use, in simple words, idea is to use cluster by X. When you want to sort the data, which is really humongous, or group by the data, which is really humongous, so you generally use cluster by. So instead of using sort by, you generally use cluster by because it has a global sorting order. It is equal to distribute by X and sort by X, meaning it is either you use this kind of a syntax where you say distribute by X, meaning you define the partitioners the way we defined earlier, that we defined a partitioner of our own choice such that all the elements in one file are lesser than one element and so on. Similarly, you could use distribute by and then sort by. This would ensure that your sorting happens using multiple machines. Okay, it ensures that for every gigabyte of data, there is one reducer. So if you have 100 gigabyte data, there will be 100 reducers and your result will be better. So cluster by is essentially most scalable version of order by. All right. So a question from Grishma is, what is the maximum data limit used for Hive? As partitions are used, so does it allow terabytes of data? Yes. So it does allow terabytes of data, because in terabytes of data can be easily fit in your HDFS if it has space available. So yes. So whatever HDFS can support, that amount of data Hive can support. All right. Now Hitin's question is, operation has no results. Is this a success? This is what I got by. Yeah. So add jar wouldn't give you any results. So if you did not get error, that means it would have been successful. Try running the actual query. You will get an idea whether the jar is available or not. Okay. So otherwise, it'll throw an error saying the class not found. So in simple words, when you want to sort humongous data, use the cluster by instead of order by. Okay. There is an idea called bucketing. So while defining cluster by, you could say into 32 buckets. This is equivalent to saying use 32 reducers. Okay. The other idea with respect to ORC is, with respect to Hive, is that we could create we could create tables in which we could update the rows, we could update the cells, we could insert the records. So that is possible by using ORC files. So if you create table with saying that we want the ORC format, then you can insert data into the table. You can update the cells and so on. So because of ORC files, Hive is not only an analytics engine, but can also be used like a database. Okay. So a question from Binta is, what is the relationship between buckets and partition? Here, partition by, you remember, it's the same partition by that we defined earlier. Here, cluster by X into 32 buckets is equivalent to defining 32 reducers. Okay. All right. Now, what does it mean by the other column? Thank you, Binda, for the question. So the row format delimited fields terminated by this. This is a special character. Let's say your data that you are going to load, the data that you're going to load into the space underscore view. There, the fields are separated by this column, and the collection items are terminated by this, map keys are terminated by this, and so on. So basically, if you are trying to load the complex data into your table, then you can use this. So here, the data is being loaded from a file called sequence file format. The sequence file format contains the data in the key and the value items, right? So the key and value, key is basically the key could be one a name, and value could be large object. Okay, value could be large object. So here the data is being loaded from sequence file format. Okay. So if you have multiple files, you can create a sequence file and save it somewhere and use that file to load the data from, okay, in the Hive. All right. Yes, sequence file is a format, again, just like we talked about. So sequence file is a format, and it's a standard format in case of many big data related systems. So in sequence file, what you do is you have, instead of creating zip file or jar files, you create sequence files. Sequence files are good for a lot of binary data. Let's say you have thousands of music files. So what you'll do is you will create sequence file containing all of the music files, where the key will be the name of the MP3 or name of your song, name of the file name, and the value will be the content of that file. So that's what is called as sequence file. Yes. Key is the, so yeah, sequence file is a binary data having key and value. Key is the URL of the file, value is the content of the file, and so on. Okay, so next thing is that, okay, all right, so okay, sure. Let's just I'll just take a note of this one here. If you could give a example of sequence file, okay, then right. I'll just see if you could give an example. All right. So you can take a look at it. Sequence file is a useful file. I'll give you a description. Okay, sequence file. Okay. So sequence file essentially is a kind of key value pairs. Okay. Not here. I'll just go back. Is a flat file containing binary key value pairs, right? It is extensively used in the MapReduce as the input-output format. All right. So similarly, that's what it is here. Let me see if we can give you a good example of sequence file. Yeah. So instead of let's say what you do is, if you have many files, what you do is you generally zip them into a single folder, correct? So instead of doing that, you generally create a single sequence file that is far more efficient to handle. All right. So the idea here was that in case you have humongous data loaded from somewhere, and you want to have, while users are sorting the data, or when you are uh, querying the data should be basically ordered by a certain column, right? In that case, either you could use cluster by as part of the table, or you could use cluster by as part of the query. Either way, you can query the data from Hive table. All right. So, all right. Next is the ORC files. ORC files are optimized row columnar format. Okay. This provides a highly efficient way to store Hive data. It improves performance when we are reading the data, writing the data, and processing the data. It has a built-in index. It has min-max values and other aggregation provided to us. And it has been proven in a large scale deployment. That's what basically from the Hive's claim. And they say that Facebook uses ORC file format for humongous data storage. All right, so let's try to see how does ORC work. Okay, so here we go. So we are creating an ORC table, first name, last name, and here we are saying that this file is going to be stored as ORC, and then we're going to insert the data into that table. Okay, so here we go again. I'm going to delete this or keep it somewhere else. All right, so that I get this free picture. Okay. Sure. So this is where I'm going to write multiple such queries. I'll say describe, what was the table name? ORC underscore table. All right. Now, this is my queries that I'm going to write. Okay. So I've copied it into the chat, and here we are saying we're creating a table, ORC table, with two columns, first name, last name, which is stored as the ORC. Okay, now let's take a look at, I'll just say formatted instead of normal one. Okay, and then say execute. So you can see here that it has created this first name, last name, database is this, creation time is this, location is this, and so on, right? So you can see that the input format, output format is this. All right. So next thing is we can now insert the data into this table. All right. We can insert the data into this table. Okay. Now, once it has done that, we can execute the select query in the same way. You can see that it has created the table. It has inserted the data into that table. Okay. We could further do the similar thing. Let's say this time we are adding John 1, Gil 2, and so on. So we can keep on doing that. Okay, let's see if we can. Okay, what does it say? It says vertex failed and so on. Let me just try again. Okay, and try again to insert more values into the table. Okay, what kind of errors are these? Could not find a valid. It's the same error which we were occurring yesterday also, right? All right. Let me just refresh this. I think it'll go away then. There's something seriously wrong, and here. Okay, so I'm going to do it again. All right, it did execute this time after I refresh the window. Okay. All right. I need to review the cluster. Something is seriously wrong with the cluster. We did review last night. It did not, we could not reproduce the problem at that point of time because this error is occurring randomly. And therefore.
What do you mean by ORC tables?
Yeah, so ORC tables are basically a different format. This data is not like plain text. The way what we were doing so far is the data was stored as plain text files. Here, data is stored in a new format called ORC, right? This is a columnar format, and okay, and basically this is used in most of the big data projects. Okay, the advantage of ORC is since the implementation of ORC in Hive has started supporting the update, insert, and delete records from a table. Otherwise, you could only load data into table and run the select queries. You could never insert new records into the table. Okay, that was the difference.
So ORC allow insert. The other our normal
Correct.
plain text it does not allow.
Correct.
Okay.
Correct. All right. Good question.
Sandeep, other tables, do they have options of creating indexes?
Other tables do no. I'm not sure if this ORC table also has indexes. Maybe they have, but I'm not sure. Okay, but the option of indexes isn't there so far, and because the only way of maybe partially indexing the data is by having the partition, so that you can only query part of the data. So as of now, there is no way of indexing the data.
Okay. In general, if you want to edit data, so we are going for ORC table, right? Because it's a columnar storage.
Correct. Correct.
Okay, thank you.
All right. Point from David is it fails the stress test. Too many users during the class. Maybe that could be one of the cases. A question from Bidao is there is a delay postponed when I run a query in Hive. That's correct. Actually, there is always a delay in one is that most of the Hive queries, since there is they will be getting converted into MapReduce phases. Therefore, there would be this delay, as well as probably in the user interface, there is kind of a delay when you click on the execute and the response comes back. Okay. So, all right. So that was an example of ORC. So you could try ORC for saving data, and question from Gaurav is that I think the main advantage of ORC is performance, as columnar data is stored next to each other. Correct. Not only the performance, it also gives you better compression because all the values of columns are stored together, so the compression generally result better. Okay. So again, what we have understood is Hive, each table has got a location. By default, the table is in a directory under this location. We can override the location by mentioning location in the create table clause. Load data copies the data if it's local. Load data moves the data from HDFS, your source directory, to the final one. Then dropping manage table deletes the data at the location. Dropping external data does not delete the data at the location. The metadata is stored in the relational database at Hive metastore. Right? Now, this part, again, I would recommend everyone to try the Tableau by yourself. You could use the Tableau to connect to Hive. So Tableau is a visualization tool. Tableau allows you for instantaneous insight by transforming data into visually appealing interactive visualization called dashboards. Okay, so you can actually visualize the data very quickly, and you can connect Tableau to Hive. You can also connect the Excel to Hive. Okay, so you can download the Tableau desktop here. Also, one more thing, these steps are detailed in the Hive project. Okay, so here if you go, I would strongly recommend that here the visualization part. Here we are showing that how to connect to the Tableau. These videos you must try, okay? Because here, if I try to show, it will take a lot of time, and you may not be able to do it right now, okay? All right. So a question is, okay, I think the main advantage of ORC, okay. A question from Grishma is, can you show us copying data to Unix location from Hive table? I'm getting error. So you could actually say is first save the data from a table using the mechanism we did earlier, right? Then you could use Hadoop copy to local. All right. So that one you can do. All right. A question from Noor is, okay. A question from Noor is, whenever I'm running insert statement, it creates a temporary table, but not inserting into ORC. Okay. So this will basically creating this temporary data. After a while, it is going to put it in the ORC table automatically when it does the consolidation. A question from Robin is that, can we practice Hive bucketing by uploading large sequence music files in CloudxLab instance and then sort sequence using SQL and Hive query editor? What is the maximum folder capacity we can store files in HDFS as a student simulating Hive and JSON? So we can you can store up to 4 GB of data, including all replication. Okay, and you could give it a shot, while we will also try to make something make it possible using that. So you could also do that parallelly. Okay. All right. Now question is, what are these values underscore tables? These are basically temporary data. When we are inserting the data into the table, it's creating those tables. Okay. A question from Gaurav, are these changes persistent like commit and rollback we do in other SQL languages? So basically there is no as such commit, but the ORC file does seem to provide, the ORC does seem to provide the rollback and the commit. Okay, but I need to look at exact semantics of ORC file. All right. So great. I would say that give connecting to Tableau hands-on proper due, because here it won't be sufficient. So you should try by yourself. Okay. Here is another hands-on you must try. Okay. So whatever we did today, you could start doing this project. This is another project that you must try. Okay. So basically we have created this data at this location. It's basically MovieLens data at this location, okay? And what we need to do is, you need to create your own table, load the data from here, first copy it to your home directory, and then load the data from there into your table, just like we did earlier. And then you do select star from u underscore data just to check whether the data is loaded or not, and so on. Okay, so I'm going to do it really quickly, and in case you want to do it with me, you can also give it a shot. Okay, so this is what we are going to do. First of all, I'm going to copy this data. Okay, so my data is in /data MovieLens, okay, ML 100K, and u.data is what I want. Okay, so I'm going to just copy that file to my home directory. This time I'm just copying the file. Okay, I've just copied the file into my home directory. Now I'm creating a table, and then I'll load this data into the table, and then I will select from this. Okay, so where is my database? So here is the database. All right. Again, these ones I will just remove from here. Okay, I'll just remove the previous queries and keep it here. All right. So in this database, we are going to create this table. Here we are saying the fields are terminated by tab and stored as text file, and we are loading data from u.data and so on. And then we are saying this. All right. So select all of these and wait for it to complete. Great. So this is what we get. So here we have successfully created u underscore data table. Okay. And then I will just try to show you my first query. My first query is running this. I'll tell you the significance of this data. This data is from MovieLens. Okay, MovieLens is a very popular data set. This data set contains movies and their ratings by various users. So it has 3 columns: user ID, movie ID, and ratings. So this user gave this movie this much ratings at this time. If you want to see the other details about movies, this particular movie, you could take a look at another file in the same folder called movie data or something. There is movie info or something. There is one more table. You can take a look in the same folder. So we've just loaded this table. Now, this data set is quite useful because this is the data set we generally use for movie recommendation. If you are looking for movie recommendation for summer holidays, you could basically use this data set and generate the movies for yourself. Okay, this Unix time is in the seconds. Okay, I think it is a milliseconds, not seconds. It should be milliseconds. You could use the Unix date. I think it's date. Yeah, it's a date command which can load this format. Okay, so it's a time since that epoch, which is 1st January 1970. All right, so here I'm executing a little complex query. I'm trying to find the average rating of each movie. And then I'm ordering the data by this average, okay, by AR. So these are 100,000 ratings. All right. What happened to this guy? Again, the same error. All right, looks like this time it worked. So this is the movie ID. This movie has got this much rating. Okay, so you could actually load the other tables as well. So here there are other tables here in this folder called data ML 100K. Here you'll notice that there is something called here somewhere you'll see the information about the users, u.item. So I think this one contains the name of the movies. Okay, and right, what if you could change the order by to cluster by? Let's say cluster by this. Okay, so internally it's going to use still one single reducer. Okay, what error is there now? Let me just reload this. I'll just change the all right, so what happened to this guy? Here, let me just try to execute this. Okay, I'm hoping that cluster by would work. Okay, I'll take a look at the cluster by later. Why it's not working? Okay, so all right. Okay, so let me just take a look at this one again at a later point of time. All right. So this is a very simple thing that we have done here. And this should give you the result. Okay. A question from Robin is, in real world scenario, where can we get those sample data showing movie analytics, etc. for practical purposes? So movie analytics, I think there are many data sets. There is UCI data sets. There are quite a few public data sets. You should take a look at those. Okay. And those data sets should give you good idea. All right. So what we just did was we were able to create this movie ratings. But what is wrong with this kind of movie ratings? Anybody? Do you find anything wrong with this kind of movie ratings? All right. Do you find anything wrong with this kind of movie ratings? Are you happy with this kind of movie ratings where what we are doing is we're just finding average of ratings and ordering that data? So okay. So what we are finding is the average rating per movie given by all the users. Okay, we're just finding average. Uh, you know, will you be ready to accept the results of this one? If somebody shows that this movie is the best rated movie, so will this result make you happy, or do you need something else? It should be collaborative. Actually, it is collaborative. So this data that you see here is the is basically collaborative only. People have provided this. A question from, yeah, good point, David. Probably I would need the movie name. So you will have to load the movie data from movie name from the u.item. So that is one exercise that you could do. Join this table with that other movie table and then show the results. Okay, so you could join multiple tables and give the results. The standard joins will work perfectly fine in case of Hive. All right, that's a good point. So if other than that, if somebody says that, okay, this particular movie is great, this particular movie is great, this movie ID that we saw is great, will you accept the results? Okay. Again, the same error.
So, Sandeep, we are trying to save this table in a text file.
We are not saving the table in the text file. We are
That
trying
is
to do analytics on this data.
okay. So it is showing as stored as text file. So
Yeah, because this data that you see u under dot data is in the form of plain text file. While loading this data, we are telling that, hey, this is the data is going to be text file and the fields are going to be terminated by /t.
okay.
Okay.
So what kind of analytic we are doing?
What kind of analytics we are doing? We are basically finding the average rating on top of this movie data.
Okay.
Okay. So the other thing we could do here is we could also represent count of ratings. Okay, meaning how many people did answer the how many people did how many people did how many people voted for this movie. So that's what I'm writing next, is that you could also take a look at the counts. Probably that would give you a better answer. So here we are saying that first sort the data based on the AR, then sort the data based on the counting. These are the movie ratings, average ratings, and these are the counts of the users who have voted for this movie. Okay, is this better for you? Now you can see that this particular movie has a kind of a bias. There were 3 users who watched the movie. They rated it. Maybe there are 3 family members who have voted for this, right? Yes, go ahead. Somebody has unmuted.
Sandeep, I have a question.
Yeah.
So, why are we using stored as text file during create table?
Because the data that we are going to load in future in this table is that is stored as text file, because u.data, this file is text file.
So we should be knowing in advance, right? What kind of, I mean, the
Correct.
source from where we're getting the data before creating it.
Correct.
So is it like we are explicitly mentioning that this table should recognize data coming from a text file?
Yes.
Oh.
Yes. Okay. We are saying that our data is going to be text file, and our columns are going to be tab separated. Okay. That's what we are saying.
Okay.
All right. So here we are able to load the data. The only challenge we are facing is that even though, like, I created a movie here, right? And my family members voted for it. And the movie, as per this rating system that we have designed, it has come in the top, right? These movies have come in the top. So what will you do in order to restrict it? Okay, in order to ensure that this looks really good. So would you like to tweak this logic of computing the average rating? Okay, thank you, Noor, for that code. Noor is suggesting that the cluster by AR has worked fine. Thank you so much. And all right. Okay, a question from Binta is that Unix time column, there are no records for some movies. Maybe actually the data is not available. Okay. All right. So yes, thank you, Prashant. I think this is what I'll do, that we will only compute the average ratings, or we'll consider only the ratings where the number of users are more than 10. Okay. So we can also join the data based on this is what I was talking about. So you could also do the same thing for the movie.data. Right here, we are creating this u.item. I can also copy that one. Let's say, how do I do? Okay, this was my table, right? So this is my file. Let me just copy the u.item to my home folder and copy, then click on home and then click on copy again. Go back to the Hive and say this. Okay, and this time I'm creating this. Okay, I'm creating this. Okay, those who are interested in this, they can do this kind of thing as well. All right, so here again, my data there is based on pipe separated. So I have just loaded only the name of the movie and movie ID from the file. Okay, so I'm going to load the data into the second table. Good. Next is that let's just join the data. So here, one more thing I'm doing is I'm creating a view here, creating a view of the previous items. So this is something I'm doing. Okay. All right. I think you'll get a clear picture out of it. So you could also try this. So what am I doing is first I loaded the first I loaded the ratings data by various users. Then I loaded the movie names. Now I have whatever the query I wrote earlier, this query, I'm creating a view on top of it. Okay, I'm creating a view on top of it. So we have just created the view on top of it. All right, next step is start analyzing the data. Okay, so now you can take a look at uh, you can take a look at the this one. All right, so this movie has the name of the movies and the movie ID. So we are joining that. Okay, joining that with the okay, let's just show you the movie data. So you can see that you have Toy Story, GoldenEye, Four Rooms, Get Shorty, and so on. And here we are joining it with our movies. Okay. Now you can see clearly that Entertaining Angels is only rated by 5 people. Sorry, it's basically this is the movie ID. This is this is the movie ID. This is the name of the movie. Its rating is how much? 5. So you can see that there is something wrong with our analysis, because the movies which we have not heard before are coming as the top movies, right? So what could be wrong? We could analyze this. Probably the main problem that is there in this. Let me just give you the entire what do you say? Entire queries here. All right, probably this you can keep. Okay, and give it a try. Why it doesn't let me copy a number of times? Okay, so I think I've already copied it for you. All right, I think it's not allowing me to copy so much of text there. Okay, so I've already done that, so maybe I'll share it later. And also it's available in the part of presentations. So what I was trying to show you is that this is how you can join between the two tables. So here we have created another table called movie information, movie m_data. And then we have loaded the same way, the way we have loaded it earlier, loaded our other table. And then we are joining it here. You can see select star from m data, comma, top 100M. This one is a view that we are creating here. We are creating a view over our analysis here, and then we are joining these two tables, and then we are executing the query here. So this way, we can combine our tables and views, and you can join them together and do the complex analysis really, really easily. Okay, imagine that you had to write MapReduce for this. I can assure you that even a senior developer who has worked in Hadoop will not be able to do it so easily. Okay, now as an assignment to all of you, you have to change these queries a bit. You have to improve these queries such that for each movies you have to count how many users have rated it, and only report the ratings of the average rating of those movies where the ratings are given by more than 30 users. Where the ratings are given by more than 30 users. So make sure that we try to run this, and it should give you good results. All right, so try to do this as a home assignment. We'll discuss this home assignment in the next session.
Sandeep, I have a question here.
Yes.
In that, so we are getting the file, right? Movie item.
Yes.
So
Yes.
definition of the table creation has only two columns, movie ID and name.
Yes.
But when I look into the file, it has
It has
there's
many
multiple
columns, so
columns.
right? So we are just saying that ignore other columns. We are interested in first two columns.
Oh, we can do that explicitly.
Yeah.
What if we want to consider the columns other than the first, first column and fourth column?
Yeah, then you have to include all first four columns.
Oh, okay, got it.
Okay.
Thanks.
Sandeep, one question, like for average rating, you are creating some other column for is average rating.
Yes, yes. So when you are, this is what you do generally. When you are creating select statement, you can create another column here. So you can see that average rating, we are giving it a name called AR,
So
right?
it will create another column.
Yes. So outcome of this will have two columns. One is movie ID, other is AR, right? And this view that you see top 100M is a view that will represent a table having two columns. Okay.
Yeah. Okay.
All right.
So, but select we generally use for only select, not to create a column.
So select is called projections in SQL. Projections means selecting the values. We can have computed columns, we can have natural columns, we can have one column repeated 50 times. So it is up to us. Okay.
Okay.
All right. Good question. So yes. All right. So a question from Intao is input data from different source with yours. Now I do it. I get the same result as yours. I input the data from different source with yours. Okay. Now I redo it and get the same result as yours. Okay. Just check if the database is selected correctly. If the data is same, then it will be different. So actually, I did not get the question. Could you show me what does it mean? If you want to, do you want to show it? Or okay, great. All right, so I think you solved the problem. Now, all right. So I think all of you got the idea about Hive. So you could create complex queries by the way of creating views or just joining the tables and doing group by, select by, where clause, and so on. So you can do a very good analysis on data, specifically if the data is structured. And a lot of conversion from the raw data into structured is possible using Hive. For example, here m underscore data, this table is here the data is separated by pipe. So we were able to load that data into this table and then do the rest of the analysis really easily. Okay, so this was a quick example of Hive. So the assignment for all of you is 1, finish the Hive project end to end. Second, finish this part. Generate the movie ratings only for those movies for which the number of users are more than 30, meaning more than 30 people have reported for that a particular movie. Okay. All right. So in the next session, we'll start with NoSQL. All right. So I think we have still 12 minutes, so we can actually cover some part of the NoSQL, and then we will start HBase in the next session. Okay. So should we start NoSQL? David says next week, please. It's just a theoretical part, so we'll just see what we can see. Okay. Noor says yes, SQL. All right. It's just a simple thing, so I think it'll be really easy. Okay, so we just have 10 minutes. So, okay. Question. So this is so welcome to a session on NoSQL. And here, there are few basic definitions which you all must be aware of. We are going to talk about the basic definitions, and then we will move to HBase. So this session is all about understanding the basic definitions, which we have already discussed in parts. So it will be really easy for you. Okay, so Bintao, the slide should be there in the NoSQL one. Okay, and I would request that take a look at those self-paced course. There, all the slides and sessions are available. This one, okay, so let me just give you the okay, so here the NoSQL one. All right. Do you see NoSQL somewhere? Yeah, here. Okay. All right, so let's get started. It's a pretty simple session. It's not going to be too hard. Most of you are already aware of things, so I'm going to go ahead. All right, so first of all, what is scale up and scale out? So let's say we have a single cart with a single horse, and we want to carry more load. So there are two options we have. First is scale up. Instead of having a horse, we have the elephant. That's called scaling up. Other is scaling out or horizontal scaling. Scaling out means adding more horses and getting a cart which can handle more load. So this is called scaling out. Now, these two options, out of these two options, we always in the computer science world, this means the vertical scaling means you had an old computer, it was kind of little slow, it has lower memory. So all you did was scaled up when there was a need of handling a bigger load. Now here, this is what we are learning. This is what we are learning, how to distribute the work. This is the harder part. This is the easier part. This easier part does not take you a very long path because today you needed to carry more load, so you added an elephant. What if the elephant cannot carry the load? Elephant may be 2.5 times more stronger than the horse, but still it cannot carry too much of load. Like if you need to carry 10 times the load, right? You can't really carry this way. Either you divide that into multiple carts, or you add more horses in the same cart. Okay, that's why we do the horizontal scaling. Okay, we do the horizontal scaling because we need to carry out humongous load at a very humongous load, which is not really possible to be done independently on separate machines. So basically, scaling out and scaling up are these two terms. Now, the four properties of standard databases that we generally discuss about is ACID properties. ACID properties are atomicity. Either when we are saving something into databases, they are all the okay. Before I move forward, ACID properties are something that all of the databases swear by. All of the databases, they swear by these four properties of the database. So one is atomicity, other is consistency, next is isolation, and fourth is durability. So atomicity is either all of the data is saved or nothing gets saved from the transaction. These are the properties of transaction which every database used to implement. Second is consistency. The database must be in the valid state after every transaction. Next is isolation. No two transactions mingle with each other. Fourth is durability. The transactions are saved. If it happens, it is saved. So almost every database, whether MySQL or Postgres or Oracle or Microsoft SQL, all of these databases have transactions, and transactions have these 4 properties. That when you are saving something to the database, it must be saved. It should not leave the database in the inconsistent state. And if 2 people are trying to save something, their work should not mingle with each other. And if we are saving something into database, it should either save completely or it should not save at all. These were the 4 properties of transactions. Now, this story is something I would like to talk about. Okay. So a question from Binta is, valid state, what does it mean by valid state here? When we are the database after the transaction, before the transaction, or during the transaction should be visible as consistent to anybody who is writing to the database or reading from the database. Now, this is something that I have seen personally, and I would like to share this. And so this is the typical story. So these are the 4 properties of RDBMS, and the entire world as of today, before this NoSQL era, have lived with databases, normal databases, right? Now, here's the story of relational databases or normal databases. Now, let's say you build one of the wonderful products of the world. You have this wonderful idea, you build a product, and now you're launching, doing a public launch, right? So you move your data and everything from local workstation and put it on a remotely hosted MySQL instance with well-defined schema. This is the day 0. The world looks beautiful to you, and your system is impeccable, is having perfect schema. Now, you do a PR, you do write to various magazines, news channels that, hey, my service is really wonderful, and so on. So your service is becoming popular, and there are just too many. Suddenly, there are too many reads hitting your server. Too many reads hitting your server, because every time a query comes to you, you will be every time a user requests for a page, you are going to query the database and display the page, right? Imagine that Amazon's detail page on which you see the product image on the left-hand side and the rest of the things. So your service is becoming popular, and too many reads are hitting the database. Why? Because every time a query comes, it queries the database, and then. So no big deal. This is something that probably every web developer around the world does. They add something called memcached. Memcached it's a memory-based caching, or you can say it's probably the de facto standard of caching. So you add a caching layer on your database. What is caching? Instead of hitting the database for every query, you keep the page ready for every product, so that for every product you don't need to render the whole page again and again. So now the service still continues to grow, and too many writes are hitting the database still, right? Too many users are adding to cart, too many users are trying to buy, and so the service is growing in popularity. It should be a good news to you, but it becomes a bad news to the DBA. So all you do is that you raise some kind of funding, and then you buy this really costly hardware, costly server grade hardware, which is like having 120 GB RAM and so on. So you're all set. You think that everything is going to work out now. All right. And this is actually the classic stage. If a company is not able to raise a fund and not able to afford a costly server, they generally used to die unhappy death at this point. Okay. And this is a story of 2000s beginning. So at this point, most of the companies would kind of cease to exist when the service is going popular, and every time the user is coming, there is like server is busy and errors are occurring, right? So at this point, if you think about Amazon's detail page, this is how it looks like. The Amazon's detail page has so many features, all of these parts that you see, the title, rating, byline, the this is called the hero bar, right? Then we have pricing, then we have in stock, the availability section, then we have the quantity section, and so on. So this is these called variations. So you see that since you raise the fund and you have this, you know, great product managers and so on, they came up with a new feature. And when you come up with new feature, instead of updating an existing table, you start adding more and more tables. And thing is that every time the page is going to be rendered, the query will become more and more complex. There are just too many joins. At this point, you denormalize your data to reduce the joins, and this is not what you were taught in the DBA, right? So I mean, one of the things that I faced personally is that first 6 months when I joined Amazon, joined DE Shaw long back in 2002, first 6 months I spent learning SQL, learning that there's something called normalization, there's something called indexing, and there's something called foreign key, primary key. And next 6 months, I spent undoing it because the data was so humongous that I could not query the data. So I was surprised to see that there was something called denormalization, that we have normalized the data too much. Now we have to denormalize, meaning instead of keeping the data in multiple tables, we try to put everything in a single table. So those kind of things start at this point of time. So there are many more steps we'll continue the RDBMS story in the next session, and we will also talk about HBase. Okay, so that's pretty much for today. We will continue our discussion next week. All right, so thank you everyone. It was wonderful to have all of you in the session. Thank you again, and bye-bye. Have a good day. All right, so we will continue the NoSQL session next week. All right, thank you Bintao, thank you Hitendra, thank you Subbu. All right, I look forward to see you next week. All right, in case you're not there, we will have the recordings and so on. Thank you, David. I think that's the answer. Could you email it to reach us at CloudxLab, because we'll mark it against with your project. Okay. When do we begin Spark? Probably next week. Next Sunday is the plan. Okay. So I'm wondering that by next Sunday, I may not be able to finish Uzi and the Uzi, Scoop, and Flume. So maybe we'll have to do that during the Spark session. Okay. A question from David is, can we review how the tools relate? Yes. All right. We will do that probably after starting with Spark. Okay, then by that time you'll have good examples. So a question from Binta, how many sessions are left for Hadoop? One more session is there, in that we will cover HBase. If time permits, then we will cover the smaller tools like Scoop and Flume and Uzi. Otherwise, we will do that during the Spark session. Okay. I hope everybody is going to continue with the Spark session, right? Is there anybody who is not going to continue with Spark session? All right, so that's what we are going to. Yeah, question from Binta is, we can also do them in Hadoop session. Correct. But the problem is that in the next Sunday, right, we had opened for the Spark introduction. So next Sunday is going to be an open session for all the Spark people. Then next Saturday after that, we would be able to do the hands-on with Scoop and Flume and Uzi. All right. Or we could do one more thing is probably one of my teammates could run through the Spark as in because how should I say, because the Spark session is starting on Sunday, and yeah, so that's one of the reasons. So I think it's okay to invite the people from this session, all of you, to that particular Spark session whereby we'll discuss the scoop flume Uzi. Okay. We may have an extra session, yes. In the middle of the week, we could have, but that'll be just too uncomfortable for many people. So I'm avoiding that. Okay. So let's plan that maybe actually it'll be useful for everybody, people even who are in the Spark session, it could be useful for them also. Okay, so we can have during the Spark session. So next Sunday we are going to start with Spark. Okay, next Saturday we will cover HBase. Okay, if time permits, NoSQL and HBase is what we are covering next session. If there are topics remaining, then on Sunday we will have Spark, and then again we can have those topics on the next Saturday. Okay, I think that'll be okay with the rest of the people. Okay, let me just write it down. Okay, so okay, I'll explain to you the challenge. So next Saturday, we will have HBase, NoSQL, and Scoop, Flume, Uzi. And actually the Uzi part is actually very much related with the people who are in the Spark also. Okay, and so that would be one thing. And so, but these parts I doubt that we'll be able to complete next Saturday. And the Sunday after that, next Saturday, is going to be Spark introduction. It's an open session with everybody. It's an open session whereby a lot of everybody is invited to these sessions. And then the following Saturday, we could actually do Scoop Flume Uzi, because I doubt if we will be able to complete this. Okay, this is a bit doubtful here. So this is the thing that I'm planning, and then we'll continue with Spark. All right. I hope this is clear. I hope this is okay with all. All right. So who all are there in the session who are only for Hadoop? Okay. Question from Robin is, what is the required prerequisite knowledge for Spark? Nothing much. Actually, we'll be teaching Scala actually. Here we'll start with Scala actually. Okay, we'll start with Scala, and that's it. Okay. So I think it makes sense to continue with Spark, and okay, so from the career point of view, I would strongly recommend everybody to go with Spark, because a lot of work is being moved to Spark. Okay, just write to reach us at CloudxLab. That should be good enough. Okay. A question from Sachin is, any practical will be covered in Hive Spark introduction? Spark introduction will be actually very similar to what we did in the big data introduction. Okay, so you may not find that too useful, because it'll be a repeat Spark one. That's correct, Vinta. So it won't be too, useful for people who've already attended. But if you want, you can just come over and it's open for all. And here what we are trying to do is this time we are trying a different thing. We are trying everybody to do a bit of hands-on in every introductory class. Okay, so that will be the only difference. Okay, great. So all right. So here at this class, because this class there'll be people who are most of the people in this class from here onwards will be the people who have joining the Spark session, either from this or from the other. But everybody will be invited for this session. Okay, everybody will be invited, and I'll have to make sure to inform my team to invite everyone. Everyone as in people from this class and the Spark class. All right, great, wonderful set of questions, wonderful set of queries. I'll see you next week. Bye-bye. Have a good day. If anybody is in Bombay, ping me because I'll be in Bombay this Saturday at IIT Bombay. I'll be giving a talk. So if you are around, give me a ping and I would love to meet you. All right. Thank you, Alvin. Thank you, Aniket. Thank you, Bintao. Thank you, David. Thank you, Gaurav. Thank you, Godwin, Grishma, Hitendra, Jay, Maruk, Rajan, Ravi, Robin, Sachin, and Supu. Wonderful to have all of you in the session. I'm really happy that all of you are able to do hands-on, and those are the things that you will remember, and those are things you'll be able to use when you join a big data team or a big data practice. All right. So thank you, everyone. I look forward to see you in the next session. Bye-bye. Have a good day and a great week ahead. And feel free to connect with me on the LinkedIn. Just drop a message that, hey, I am from the class, because there are just too many ad requests that keeps on coming on LinkedIn. All right. Great. Wonderful to have you in the session. Bye-bye. Have a good week ahead.